Greetings and hi everyone. My name is John Soul. I am a TIA auditor and trainer at EPI. Today I'm going to give you an overview of the content of the certified TIA-942 Design Consultant course. This will give you a very good understanding of what to expect from this training, and I hope you will really enjoy this preview. The certified TIA-942 Design Consultant course is intended to give participants a full understanding of how to design and build a data center according to the TIA-942 standard. The course comes with the latest TIA standard, the TIA-942B July 2017 edition. It is a 3-day course, so let's look at the agenda. On day one, we'll look at an introduction to data center facilities. We'll talk about the standard and its development. When designing a data center, we need to do proper planning, in particular around spaces. The higher the rating levels, more spaces are required. We'll look at various data network topologies, depending on the size and scale of your data center. It could be an edge data center, or it could be hyperscale. We'll look at various recommendations for energy efficiency, as data centers are large users of energy. TIA system looks at many parts of a data center, of which architectural is a critical area. We'll also look at how you will secure and make your data center safe. On day two of the training, we'll look at various aspects around the building, the site, various rooms, how to get access to the rooms, how to control access to rooms, and how to design the various spaces from computer rooms, entrance rooms, and supporting areas of the facility. We'll also make a start on the electrical systems, from all the way from the power company, from the feeders, transformers, down through the main switchboards, all the way down to the computer rooms and computer room racks. So we'll look at generators, UPSs, and all the various systems in the power chain. Obviously, the different rating levels will have different requirements around number of power chains, number of feeders, number of UPS systems, etc., etc. On day three, we will look at the mechanical systems that support the facility and the computer rooms. We will also cover telecommunications, looking at all aspects of telecommunications from a topology perspective, as well as an implementation of the redundancy systems for the various rating levels. After the training is finished, we will do an exam to test the learnings. The exam will be closed book. It is 60 questions. The good news is we give you the answer, but you have to choose the right one, being a multiple choice exam. 90 minutes to do the exam, and the pass mark is 50 out of 60. So it's slightly higher than some exams because we want to make sure that the designer is fully qualified when designing data centers that could impact on the delivery of the site. Okay, so let's go and look at some of the modules. Under module 1, we'll give an introduction to data center facilities. So after this lesson, you should have a very good understanding of the purpose of a data center, the importance of high availability and how to achieve it, and obviously the cost of downtime. We'll also look at the value of the ANSI TIA-942 standard and what benefits it should bring to the clients or customers that deploy it. We'll have a high level definition of the rating levels to fully appreciate the intent and objectives of the rating levels. On this slide, we can see that data centers are very complex spaces. We have telecommunication systems, we have electrical systems, we have architectural systems, and we have mechanical systems. So the TIA system will give us a very solid, strong foundation and framework from which to remove this complexity. For example, there is a misunderstanding in the industry that I need to have multiple power companies. This is incorrect. We only need to have one power company. On this slide, we can see why ANSI TIA is one of the preferred data center standards for data centers when benchmarking or designing a data center. It is a real standard. It is issued by an ISO standards organization. It covers the whole environment of a data center, covering telecom, electrical systems, architecture, mechanical, security, safety, fire suppression, and energy efficiency. So remember the word team. So let's have a quick look at the rating levels and their expected outcomes or intent. The rating levels were provided to give data center owners a level of understanding of expected uptimes or availability. Rated 1 data center will provide the baseline availability. It will meet the need requirement of the data center. Rated 2 will improve the availability by adding redundant components. Rated 3 and 4 data centers will give us higher availability expectations because, one, they're both concurrently maintainable, so we should be able to do maintenance and keep the data center running from an end user perspective. Rated 4 is also fault tolerant because it has the ability to automate the recovery from any one fault within the overall data center infrastructure across telecom, electrical, and mechanical systems. Obviously, the availability of the data center will also depend on people, processes, maintenance, training. Under Module 2, we'll have a good look at the system and how it was developed. As we can see on this slide here, we will look at the organization and the process behind how we release, maintain standards. We'll look at the accreditation and accreditation systems that are put in place. We'll look at the areas under scope. We'll look at the various redundancy definitions and requirements to greater depth. And we'll look at various definitions and requirements around the critical terms, concurrent maintainability, compartmentalization, and fault tolerance. On this slide here, we can see the three major components to a quality ISO-based accreditation scheme. In this particular case, we have the organization which creates the standard, which is TIA. They are the standards development organization. They own the scheme. We have an organization called CERTEC who are put in place by TIA to manage the certifications and the certification bodies. So they are the program manager and accreditation body. We have the various companies that can provide conformity assessments and can conduct the TIA external audit certifications. The certification companies like EPI will do an audit. They will then recommend and submit to CERTEC for approval. CERTEC will then check the systems that are in place, check the processes and the audit that was done by the auditing company, and then they, upon acceptance, will then publish the certifications on their website, which is the TIA-942.org website. By having the system, not only do we have someone producing the standard TIA, but we also have the scheme owner also having a system in place to check that what the outcomes of the various audits are managed in a quality framework, which will build trust in the industry. The training will come with a full copy of the latest standard. The official standard is the TIA or ANSI TIA 942B standard, is the telecommunication infrastructure standard for data centers. Telecom is at the core, however, it addresses other areas of the data center, including the electrical, mechanical, and architectural elements. The annex chapters are also part of the overall certification scheme when you wish to comply to the ANSI TIA-942 standard. It is divided into the normative sections, which is the telecom sections, and the informative chapters, which cover the facilities areas, electrical, mechanical, and architectural. So therefore, we include all sections of the standard when looking at the overall design criteria of a data center which desires to conform or comply to the TIA 942 standard. During the training, we will do a comprehensive look at the component redundancy levels. We'll look at the N plus 1, 2N, 2N plus 2, and we will remove the misunderstandings of these various redundancy components. During the training, we will also give you high-level examples of how to interpret and apply the various rating levels. In this particular case here, we've got an example of a rated 3 data center, which is concurrently maintainable. In this particular instance, we're just showing you the power and cooling, but we will also cover the network distribution paths as well. Concurrent maintainability is one active path and a redundant component path, or redundant path to allow us to do maintenance and keep the IT running. Under Module 3, we will look at how to plan for various spaces within the data center facility. So under this, the objectives of this particular module is to look at planning those spaces, considering what size they need to be, what complexity is required in each particular space or area. How do we secure those spaces? How do we route from one space to another to ensure we can do maintenance? So depending on the purpose of your data center, whether it's a colo, enterprise, very small data center, you need to design a variety of spaces and areas to support the overall data center. During the training, we will reference various parts of the standard, which will give you information on whether multiple rooms may be present or will be required depending on the rating level. For example, rated 4, we need to have compartmentalized spaces. As you can see on this particular slide, there's lots of spaces we need to consider for size and height and purpose. We also need to consider whether they're work areas, whether they're surface areas, and they are sufficiently sized to meet the required rated levels. We need to consider how we get goods from the loading bays through to the holding areas and staging areas, computer rooms, and maintenance areas, taking into consideration the size of equipment and loading factors. We'll also look at how power and network connectivity is provided, how diverse it is it coming through separate duct systems depending on the rating level we're trying to achieve. Different rating levels will have different security measures to control access, and we'll also look at the requirements around CCTV. Data centers need to have high quality fire protection systems, so we'll look at the various sensors that are required. We'll look at whether VES.HS, the HSSDs are required, and which type of suppression systems we can use and what sort of spaces will be required for them. We'll also review escape paths to make sure we're compliant to local regulations for safety, as well as we'll look at how to properly design so that we can maximize spaces, separate the disciplines to ensure high availability. We'll also consider zoning for fire protection in consideration for TIA standard, as well as the area having jurisdiction or your local fire codes. Quality data centers will also need to have appropriate monitoring systems in place to control, monitor, and automate various attributes. Module 4, we will look at the various network topologies that will apply to different size data center buildings. Under the objectives, we will look at the various telecommunication spaces which are required at various sizes of data center. We'll look for what spaces and their purposes, and we'll look at some of the major topologies which are used. On this particular slide, we can see the typical spaces which are required by TIA and their typical descriptions. With the exception of the MDA and EDA, maybe not all of these spaces will be present in smaller data centers. This slide here is an example of one of the topologies, the distributed topology, which is typically designed for very complex data centers, which are typically rated 3 or 4 data centers, where we have complexity, we have circuit lengths, we have security measures, and we may have redundancy requiring multiple distribution areas, multiple distribution paths, multiple areas. TIA also makes recommendations for energy efficiency in Module 5. Obviously, data centers are large users of energy, so therefore we need to consider why it needs to be green, why it needs to be sustainable, and we'll look at various parts of the infrastructure which could influence the energy efficiency, from cabling, what measures we can do to improve efficiency, how to remove inefficiencies. We'll also look at various systems which we can use and apply to measure and check that we've got a data center which has good airflow. We can use computerized systems like CFDs and how to use them to design facilities and racks to optimize our cooling. We'll look at the various containment systems and how they will help improve efficiency. TIA also talks about various other ways like putting blanking plates and other considerations to improve efficiency. As part of the ANSI TIA-942 schema, it makes reference to ANSI TIA-569D, which is a cable tray and pathway standard, which gives us guidance and recommendations around how to run cable trays, how to run pathways, how to place them. It also gives us some feedback around in terms of floor loadings and what you need to do if you're running cable trays either overhead or under the raised floor system. However, overhead is preferred. TIA also makes considerations or advisories around how we can improve energy efficiency. So it will recommend or advise that we do containment systems, whether it be hot aisle or cold aisle or self-contained racks, because it will all aid in creating a sustainable data center. TIA also gives us direction around using other lighting systems to improve energy efficiency. It also recommends that we do proper monitoring and usage, and when designing our data centers, ensure that we can reduce solar gains, make the data center more energy efficient by not having external windows into our data center spaces. We should also be monitoring equipment and power to ensure we're not underutilizing, and most data centers have an issue where they do not remove unused equipment. Under Module 6, we will look at the architectural elements that apply to TIA. So under this module, as you can see, the objectives are: 1, considering your site and your location, and TIA gives us lots of direction around choosing the right or best sites for the long-term reliability of data centers. TIA will also give you considerations around when selecting an appropriate building or building a greenfields data center. There will be various architectural elements around car parking, building construction types, roofing, floor loadings, whether you use a raised floor system or not, or a suspended ceiling. And if you do use these particular infrastructures or constructs, how to implement them. If your data center is in an earthquake zone, you need to ensure that the buildings and infrastructures are appropriately braced and mitigating against seismic activities, which could also be vibrations. On this particular slide here, it will reference various parts of the standard that we need to consider when selecting a site. We also need to consider building and state and local codes when applying or building a data center, because codes are enforceable by law and we need to have a thorough understanding of our legal requirements, and TIA makes reference to TIA standards as well as ensuring that you always comply with your local area having jurisdiction or your local codes. As per the slide, TIA also makes sure that we consider environmental laws as well as zoning laws. We want to ensure that human activity does not create issues or environmental consequences on the environment through the activities of being a data center provider. So both zoning and environmental laws will impact on the design requirements of the data center, and during our training we will look at various aspects around storage, generation and emissions. At all times ensure you understand your regulations and record your requirements as an auditable trail. TIA also gives us direction around choosing buildings. We need to make sure that any building, whether it's an existing building or new building, is free from dangerous and harmful or contaminating substances, of which asbestos is one of those materials, often hidden within various products. During the training, we will look at the various building construction types and how to apply them to the rating levels to ensure that you're compliant to the TIA standard. Obviously 680 pages will take a long time to understand, so we will remove that complexity and just focus on the requirements from a TIA perspective. Many data centers are still using raised floor systems because of the flexibility they tend to give from a cooling perspective. So during our training, we'll look at how to build and design a data center, again according to the ANSI TIA 569C C standard, which is referenced by ANSI TIA-942. And here we have a list of attributes that you should apply when installing and designing a raised floor. So in terms of a snapshot of objectives, we'll look at physical separation requirements depending on the rating level you're trying to achieve. Remember, rated 4 has compartmentalization, rated 3 has a preference for it. Higher the rating levels, greater the requirement for CCTV coverage, and we will look at those various aspects. We need to have various systems in place to control access to the site, to the building, to the restricted areas. So we'll look at various controls that data centers will use. We also need to understand the different type of locking systems. TIA has a requirement for bulletproofing requirements, and more so in the modern data center as we are now more risk averse. There will be various requirements around ensuring we have sufficient light to ensure the CCTV systems will work, and we need to make sure the cameras are appropriately placed. By law, we need to consider emergency lighting and emergency exit signage and ensure all pathways are free and easily accessible. This slide will demonstrate some of the attributes of CCTV systems. They should be digital. We should be recording all activity. They should be 20 frames per second to provide proper motion image of the recording. As per the various rating levels, we will be required to have various systems and man traps and portals to ensure that we have a highly secure data center. And as part of the training, we will look at these systems, which ones are appropriate, which rating levels we will apply them to. One of the aspects of architectural design for a data center is, under the TIA standard, is to ensure that we have an appropriate level of ballistic or bulletproofing at the main security counter. Higher the rating level, greater the requirement for having full control of your data center. As part of the training, we'll also look at how to implement emergency lighting, emergency exit signage, as at all times our lights and signage need to be placed or shall be placed as per the directions of the AHJ. So there's a lot of mandatory requirements. Data centers obviously are not office environments, so we need to do additional enhancements to make the data center safe. Under Module 8, we will look at the building and room access requirements according to TIA. The objectives of Module 8, we will look at whether security checkpoints are required for the different rating levels and how to apply them. We'll look at entry lobby area, which is the area where we enter the building. We'll look at TIA's requirements around floors, windows, fire ratings, and ensure at all times that you have your exit corridors appropriately implemented to meet your AHJ. We'll also look at loading docks, how goods are brought to the site, how they're offloaded, and how we control those processes. As you can see on this slide here, we can see that security checkpoints only apply to rated 3 and 4 data centers. They're at the primary entrance point, and obviously they should be awake and doing their role 24/7 in an appropriate manner. TIA gives us a minimum set of exit corridor requirements, such as appropriate fire separation and an appropriate width for the exit corridor. However, they are extremely, for something that seems simple, the means of egress are complex laws and codes, so we need to ensure that we have a strong understanding, and as a designer, make sure you also use your subject matter experts in these areas. With the TIA standard, we need to consider how goods get to the site, how they get onto site, and how they are offloaded and loaded via the loading docks, and what protective measures we should put in place. Module 9 will look at the various rooms and spaces and their design requirements within the data center facility. In this module, the objectives will be to look at the physical separation requirements for the different rooms in the data center facility, what sort of fire separation is required based on the rating level you're trying to achieve. We obviously need to have an appropriate aisle width so that we can maintain, repair and service mechanical and electrical equipment. We'll have an in-depth look at generator and fuel areas and how to apply them to the various rating levels. And obviously the important critical area of the computer room, what requirements are needed to have a fully compliant space. So within the data center, we will look at the various spaces like administration areas, network operations center areas, computer rooms, staging areas, and what are the requirements around power delivery, cooling, windows, fire separation, and how to cable the various spaces according to the commercial cabling standard. On this slide here, it demonstrates the current requirements of the latest standard for generator and fuel storage areas. You need to follow the latest standard as opposed to previous standards, because the current standard now allows generators to be placed inside the building for both rated 3 and 4, provided they meet a minimum of 2 hours or higher if required by the local code. TIA also gives us good direction in how to build a computer room, how to choose a location, considering the size of the computer room for not only its current design but its future growth as well. Consider how goods get off the truck and into the computer room and back out again, and ensuring we have an energy efficient data center by ensuring we do not have external windows. However, if we have internal windows, we need to make sure they meet the appropriate TIA requirements for security, heat load, and fire resistivity. A lot of data center designers or installers make or create issues for themselves because they do not put the lights in the appropriate locations. So Lighting should be in the aisles, not above racks, not close to cable trays. Emergency lighting has to be installed according to your local code, and we should be using energy efficiency lighting systems. Under Module 10, we will look at the various aspects around the electrical systems when designing a quality data center. Under this module, we will look at the requirements for the power chain, all the way from your power company, transformers, substations, switchgear, all the way down to the SDSs, PDUs, and power strips in the racks. We'll have a good look at generators and fuel supply configurations depending on the rating level you're trying to achieve. UPSs and battery, there will be various configurations, again depending on the rating level you're trying to achieve, and there may be requirements around the AHJ. We'll look at the grounding requirements from a lightning, telecom, and electrical code requirement perspective. We'll look at the requirements for surge protection or surge suppression, and obviously to have a energy efficient data center, we should be doing appropriate power monitoring. To get a quality data center, we'll look at what you need to do for testing and commissioning depending on the rating level you're trying to achieve. Equipment maintenance is also part of the TIA scheme in terms of applying an appropriate methodology, appropriate maintenance, appropriate facility staffing, depending on your availability, uptimes, and the rating levels you're trying to achieve. On this slide, we can see what the TIA requirements are for substations, depending on the rating level. Rated 1 and 2, we can have a single substation, single feeder. Rated 3 and 4, we need to have dual paths, but rated 3 is N+1 from a system perspective, so at any one time we only need one active and one standby. Rated 3 and 4 data centers should have dedicated feeders for the data center. As part of the training, we will look at the various power system analyses you need to do. The reason we do these power system analyses is to ensure the safety of the electrical installation and to ensure that people are wearing the appropriate safety protective equipment. We also want to make sure that we do the appropriate short circuit studies to ensure that any potential short circuit current at any point in the installation does not cause a cascading effect. During the training, we will show various examples of generator configurations for the different rating levels. In this particular case here, we're showing a typical rated 4 2N redundancy system offering total building support. Obviously rated 4 has to be automated and fault tolerant to be able to sustain one fault anywhere in the system. We will also look at the various requirements for TIA when implementing ties between switchboards or between infrastructures. We need to ensure for rated 3 and 4 that the tie arrangements are concurrently maintainable, which means we need to have a main tie main configuration. As per the slide here, we will also demonstrate to participants in the classes how to apply an appropriate UPS configuration, in particular how the static bypass, external bypass, and synchronization is provided in a TIA compliant data center. Within a TIA compliant data center, we need to have the 3 grounding systems. This particular slide here is an example of how the telecommunication clean earth or the telecom grounding system should be implemented to ensure we have an equipotential grounding system to protect the ICT equipment from high frequency noise and from electrostatic discharges. During training, we'll also show you how to build a compliant grounding system within the computer rooms and how the various components from racks, cable trays, raised floor systems are grounded back via the distributors which are the SBBs or secondary bus bar bonding points, and how they are wired back to the main grounding system of the building. Under Module 11, we will investigate and look at the various mechanical systems in the data center. Mechanical systems typically refer to cooling systems. However, they also relate to other aspects as well in terms of environmental specifications. So we'll look at the various requirements around ensuring that we have a compliant data center. We will look at various contamination sources and how TIA recommends we prevent or mitigate against them. We'll look at the various cooling systems and the configurations and how to apply it to the rating level. We will look at various condenser makeup water systems. We'll also look at other varieties or types of cooling systems, including air conditioning systems, DX systems, central cooling systems, control systems. We also need to consider aspects around piping, plumbing as well. And data centers need to have the appropriate fire suppression or fire protection systems in place. TIA also has a requirement to ensure that we have an appropriate water leak detection systems in place in critical areas. TIA gives very good direction around how we design the environments. So the environmental specification from TIA will look at various aspects around choosing mechanical components. We need to consider how various contaminations like particulates, water, can impact on the reliability of ICT equipment. We also need to consider aspects around climate, aspects around chemicals, contaminations, and how temperature and humidity will impact on the long-term reliability, and how contaminations plus humidity levels will also impact on the long-term reliability, and how we should be mitigating against these particular aspects. We also need to consider electromagnetic fields and how they can impact on equipment, and how electromagnetic fields can impact on people, spaces, often referred to as mice. Not those little furry things that run around your data center, but the mechanical ingress, climatic, and electromagnetic. It has 3 levels, where level 1 is the most restricted. In terms of computer rooms, we follow the ASHRAE recommendations. We will look at how to achieve the appropriate levels of mice. So in the case of C1 or climatic, we need to choose the right location for our data center, and we need to design our data center in an appropriate manner. So when choosing a good site, we need to consider the various sources of contaminations. Could be EMF, could be radio frequency interference, can be various gas contaminations, or it can be something as simple as vibration through the ground or earthquakes. We will also look at the various aspects around temperature and humidity recommendations. TIA references ASHRAE 2015 as the guideline for data center computer equipment. ASHRAE has a range of requirements depending on the equipment type. ASHRAE will look at the recommended dry bulb temperatures, and it will look at the recommended humidity levels for long-term reliability. But if your equipment is of a different class, we may be able to run the data center at higher temperatures and wider humidity levels. ASHRAE focuses on the data center industry, and it has a technical committee 9.9 who focus on that particular space. The key for ASHRAE is to ensure, again, long-term reliability of computer equipment, but also it's looking at how we can use free cooling on a greater scale as well. As I stated previously, as part of the mechanical systems, we will look at the various water systems or water-cooled systems. in this particular case, an example of a rated 3 and 4 system. We will also look at air-cooled systems as well. We will look at the chillers, we'll look at the crack units, we'll look at how to achieve N+1 capability. We should also not only consider the physical components, we need to also consider the pumps, the pipes, and electrical feeding as well to ensure we have concurrently maintainable systems. Under Module 12, we will have a very strong look at the requirements for telecommunications. Under this Module 12, we will look at the various network and data center topologies, and we will look at the various spaces that should be designed and implemented depending on the type of data center rating you're trying to achieve. We will look at those redundancy design requirements to achieve your desired rating level. We'll also look at which media and connectors are approved by TIA if you're designing a modern data center. We also need to consider cable pathways and risers and ducts and how to route them to the critical spaces. We also need to consider how to administer and label, because TIA is very strong on having appropriate controls around labeling of the telecommunication infrastructure and critical electrical and mechanical systems. We also need to make sure we have the appropriate testing of the different types of media. We also need to understand the various cabling types and guidelines around data center fabrics and various distances that the technologies can work over. This particular slide here demonstrates the high-level scheme of the data center topologies. It also shows the standard defined terms according to TIA. Any data center can be represented by this high-level topology diagram. However, a smaller data center may not have all these components, or some of these components may be merged within a similar space. However, we have dedicated areas for handover from the access providers and campus cabling, whereby we then patch over to backbone cabling. But each of these particular areas is a distributor with a defined purpose, and part of the training will be that we will look at each component and its purpose and whether we need to implement them according to your rating level. TIA-942 references the TIA 569C standard. The 569C standard will specify pathways and space designs and various construction practices in support of the telecommunication media and telecommunication equipment within buildings. When designing the pathways, the quantities of cabling for today and future expansions should be considered within the overall process. We need to pay particular attention to the various intersections of cabling pathways and the different distributors. Here is a quick reference table which shows the minimum separation requirements between twisted pair cables and power cables. However, it is always good to ensure that we have further separation to ensure that we do not have issues with power interfering with our telecommunication networks. We also need to consider separation from other sources of interference like lighting fixtures as well. But the 569C gives us good direction, and we'll cover that as part of our training. TIA 942 references the TIA 606 series of standard. The 606 series provides guidelines on how we do cabling administration. The original TIA 606A was designed to identify and record general administration, but it did not address the specific needs of a data center design and installation. The latest TIA 606C will cover that. It gives us guidelines on labeling, record keeping, how to control an implementation using a move and add change methodology. It should simplify maintenance and troubleshooting. This brings us to the end of the sneak peek of our CTDC training course. Further details on this training can be found on our company's website using the URL given on this slide. I hope you have enjoyed this sneak peek. I would like to thank you for your attention, and we're looking forward to seeing you at the CTDC training. To contact us, you can use the email address as per the slide here, so sales@epi-ap.com. Thank you very much.